one of those make or break tools in the shop. Aside from the finishing on a project, it's the miters that draw the critical eye and actually separate the woodworker craftsman from the hacker. Let me show you some techniques to set this saw up to operate as it was designed and make those miters something you'll envy. Now, miters are made for cross-cutting, which means cutting a wood across the center, and they excel at cutting 90 degrees at bevels, which is on the back side of this, and miters on the front. And their capacity is mainly built around the type of saw and the size of the blade that you've got. This is a plunge saw, simple plunge saw, so that the capacity of the saw is just a little bit less than the diameter of the blade. If this were a slide miter, you would measure the length of that slide to determine its capacity there. Now, because this saw is not made for ripping, only for cross-cutting, the blade that you use can have a much greater tooth count and much narrower space between the gullets. In this case, now this is a 12-inch saw blade, there are 80 teeth here, and you could go up to as many as 100 depending upon the manufacturer. The more teeth equates to a cleaner cut. And you'll also find on a miter saw blade, as opposed to a table saw blade, you want a negative hook angle. In other words, on a line from the center of the blade, that tooth angle would be slightly behind that line. It provides a slightly less grab when you're cutting and provides for a much more downward cut, leaving a cleaner cut when you're done with it. The first adjustment we're going to make to this saw is making sure that the blade is 90 degrees to the table. So on this particular saw, if we lock down the blade, I'll set a small little machinist square up against the blade body. I don't want to touch the teeth here, I just want to touch the blade body. In this case, the square lines up nicely and shows that the blade is at 90 degrees. If I were making adjustments, on the back of this particular saw is a hand wheel that will loosen that bevel. It'll allow me to set that blade at 90 degrees, relock that bevel, and then set the stop, which is on the post on the back side here, to 90 degrees. And as always, we would back it off of that stop, then push it back. But I've got one more test to show you, more visual way of cutting a piece of wood and laying those cut ends back together to show you whether or not what you've set is a perfect 90. Now I've got this piece of 1x3 stock. What I'm going to do is just stand up in the back here, cut straight through that 90-degree cut, and flip those pieces end for end to see how well that cut line lined up. And you should see a really nice match because this is set at 90 degrees. Okay, now here's our boards as they were cut. We'll flip them end for end and put those pieces back together. And we have a very pretty straight cut. Now that we've established the 90-degree cut, it's time to check the 45-degree angles. This particular one swings both ways, so we're going to check them on the left and just show you how that would work on the right also. So I'm going to lock down the miter like I did before, loosen the knob in the back, and swing this to the stop that's already set at 45. To make sure that stop is operating correctly, got the top to my combination square. Just going to slide that in and check and see how it fits up against the blade. You'll notice in there that it fits actually pretty well. So this again shows that the miter's been set for 45. If the miter did not show that well, if it had an opening at the top or the bottom, the adjustments are made in the back of the saw. There's a couple of hex head bolts in the back that are adjusted in or out to allow that miter to lay down a little bit more or stand up a little bit more. On the left side miter, the whole process is reversed when you come to do the right side. So that's the setup there. What I want to do now is show you, since it is set up, another way to use a couple of pieces of wood to show how well the setup that you set on there produces a nice square picture frame, let's say. Now with the saw set at 45, I'm going to use these 4 pieces of stock to determine whether or not the sets I made on here are correct. And they're all the same width, which is important. They can be any length. I'm going to cut the 45 bevel on each of the 4 sides, flip them around and put a stop block on and recut those. And then we'll put those together to resemble a deep picture frame in effect and see how well those miters turned out. So let's get started. Now that all these are cut, I'm going to lay them out and let's just see what they look like with a little bit of tape around them. There's the telltale piece of tape. And these bevel cuts are all but perfect. So there's really no reason to go back and adjust them. I think anybody would be happy with the looks of those. Now the next step in the adjustment is making sure that the blade is 90 degrees to the fence. In doing that, I'll just lock down the blade and use a plastic triangle. Now we want the plastic triangle to touch the blade body, not the blade teeth. That would throw it off. So we'll set it up against the fence on the back side and slide it up and see how it aligns to that blade body as it runs down its length. And again, here the adjustment is pretty good. If it were off, there's a couple of things that you can do, and it depends on the type of saw that you have. In some cases, the fence is fixed. There's no way to adjust the fence. So the way to make those adjustments, and that's the case on this saw, is that underneath this miter gauge, there are 3 bolt heads. Loosening those bolt heads and adjusting the stop so that it's sitting at 90 and locking it into that spot. If I want to make sure that the blade is parallel to the fence, in this case I would actually move the blade back and forth to line up with the edge of the square. Once I've gotten that, then I would retighten those bolts, and in effect what I've done then is move the miter gauge slide to make that adjustment. Now in a second type of saw, it's the fence that's actually adjusted to the blade. In those cases, what you'll do is loosen the 4 bolts, there's normally 4, 2 on either side of that fence, and using the same plastic triangle up against the blade body, we're going to align the fence this time to match up with that triangle. Once you've got it, then you're retightening those bolts. Now that's in a 1-piece fence. Some saws come with a 2-piece fence, so each one of those adjust individually. I normally, to make it a little bit easier, will take a 2x material or 1x material, clamp it to those fences, so now I've set them in effect as a 1-piece fence and use the same alignment system I would have done with one. Once those are adjusted, and once your alignment is set at 90 degrees, all the rest of the detents fall in line because they have to. They're all machined that way. So once the 0 is in line, the 22.5 and the 45 are automatically in line. I want to show you a way to test both the 90 degree or the 0 and the 45s on either end with a set of blocks. So we're going to show you how to cut those and match those pieces up. That will test whether or not the setups that you've made on here are accurate. Now to test the 90 degree, I've got a small piece of 1x material here. Edges are parallel, and I'm going to cut it in half and then flip those end for end, and you'll see that that cut lines up. So now if I take these 2 pieces, this is how they were cut, and flip them end for end, I should get, and I do, a nice clean gap-free line, which means that that miter is set perfectly at 0 or 90. Now the second part of this test is to test the 45. And again, once the 90's been set, the 45s at either end are fixed. There's no way to change those anyway, so I just want to make sure that they do line up. So I'm going to slide the miter gauge over to 45, and I'm going to cut each one of these pieces. Then I'll put a stop block in, cut the other side, and we'll make, in effect, that big, broad picture frame and see how well those miters line up. Oh, and that looks really good too. So these are really nice miter cuts. Looks like our 45 is right on the money. No reason to go back and check that. Now our miter is laid out beautifully, but let's just say you've done a project, and this is kind of a little quick tip here. You've done a project where the miters didn't work out quite well enough. Either the tips were touching or the heels were touching. So in other words, it's open at the top or open at the bottom. A lot of woodworkers will try and override the detents or the positive stops in here and move that miter just a half a degree or quarter degree each way to make up for that difference. And it's kind of a guessing game. I have a much better way to do that. It works every time, and I'll show you how easy that can be to take off just a little bit of the tip or a little bit of the heel without making major adjustments to the miter gauge itself. So here's how this works. The idea here is that we're going to use the blade body. Going to pull the saw down and use the blade body itself as a stop. So I'm going to slide this piece of material up until it just touches the blade body. If I want to take off more of the toe, the front of this miter, than the heel, just take a business card or a playing card and put it behind the front edge of this material. In effect, what it's done is it's moved this material away from the fence and exposed a little bit more of the point or the toe into that cut before the heel. If I want to take more of the heel than the toe off, I move this card to the back side, which kicks out the back end, moving a little bit more of the heel to that cut as opposed to the toe. So sometimes it's easier to show than explain. So what I want to do is first we'll put a pencil mark on here like this, so you can kind of see that I'm going to take off this material. And in this case, I want to take off a little bit more of the toe, front part of this cut, than the heel. So I'm going to slip the business card in the front because I want to take off more of the toe than the heel. I'm going to slide that piece of material up until it touches the blade body. No real pressure on it now. Pick up the blade and recut. Now what you can see here is that I've removed the pencil mark, or a lot of it, and the pencil mark is less on the toe than it is on the heel, which means I've taken off a little bit more of the toe than the heel without having to move the miter gauge at all. Sometimes when you move the miter gauge, you'll kind of tweak it a little bit, a half a degree one way or the other. You'll lock it down, and then you'll forget that you did it. So when you go to cut your next miter, now you've made it worse the opposite direction. So leave this where it is, lock it in, and use the blade and a business card to do that trimming. Works every time. Well, it may seem like a small thing, but it's kind of important to me. When you're cutting off a long piece of material, you may find that that material begins to tip at the end of this relatively short bed. So you're putting an inordinate amount of hand pressure relatively close to the blade while you're making that cut. I think in those cases, it's a good idea to have some kind of support, something a little bit longer to give that wood some way to balance on this table. In this case, we've got a stand that's got some roller supports on it. Now you can put your own rollers in. You can even build your own little 2x4 frame if you've got it on a workbench. But these adjustments are fairly easy. You can see this tips fairly easily now. All I'll do is raise the support so that the bottom edge of that board is supported evenly along the table. And there we are right there. So that now as I run this piece of material, it's running over the roller support at the same time. It's a great way to balance them. Again, you can get these as aftermarkets. Some saws come with them, or you can build your own, but I think it's important to use them. Now, you may have noticed a little bit earlier that I was using stop blocks to control those mitered pieces and make sure that the lengths were all the same. I really like to use them. I find I'm using them all the time. I know that most woodworkers, and I'm guilty of that too, will occasionally use a pencil on the base to decide where you're going to put these, but after a while the base is filled with them. And sometimes looking down on that line can change the dimensions of the material, especially if you're cutting a lot of them. The only thing I would add when using a stop block is to set it just a little bit above the base of the table. This allows for any possible sawdust to push away from that rather than accumulate in front. Now, as an alternative to that, you can taper or chamfer the edges of this. That does the same thing, but that will really help when you're setting up your stop blocks and using them to make sure that nothing interferes with getting perfect cuts every time. In addition to stop blocks, they're hold downs. This particular one comes with the saw. Not all saws have them. Some saws have them available as an aftermarket purchase. If you can find those, or if your saw comes with them, I would suggest that you use them. And the reason is, when you're cutting miters in particular, I find that a lot of miters have a tendency to creep into the blade. As the blade cuts it, it seems to pull that miter a little bit closer. And if you multiply that creep by 8, the number of times you cut 45s, it's a lot of times why your picture frames don't turn out well. So here, if I put them in the correct spot, and I used my hold down to hold that firmly, there will be no creep when I'm doing it. And on smaller pieces, it keeps my hand away from the blade. So stop blocks and hold downs are two things I would think about. Again, I think that they're a good addition to your saw and a good addition to what you normally consider good practice when you're working with miters. Now, cutting large pieces of trim and stock on a miter saw is generally not much of a problem. It's when you cut very small stock that you get into a little bit of trouble. Remember, the rotation of this blade is going back, and without support on the back of that cut, a lot of times the pieces that you cut are going to just kind of be blown out of there. And cutting small pieces too can be somewhat problematic. I want to show you a little technique that will kind of take care of those problems, and it's relatively easy to do. This is a piece of MDF, a little 1/4-inch piece. You could do it with hardboard, you could do it with a thin piece of plywood. I'm going to use some double stick tape and actually tape it to the fence supports on the back side of this. Once I've cut through the saw blade, first time, I will have a nice kerf line in here which establishes, as in effect, a zero clearance for cutting really small pieces and really fine trim on the end of any stock to keep the blowout from happening. So first we'll take a couple of pieces of double stick tape and we'll affix it, and then I'll show you how that works. Okay, so now I've got a really nice clean line there, so I know exactly where that blade is going to go on both the left and right side. And to provide some support for a fairly small piece like this that would normally splinter like crazy when I cut it, you'll see how clean those cuts come out when it's backed up by something. Normally that little piece would come flying out of the back of the saw. It was stopped really effectively here by that small little piece of material on the fence, and the cut on the back is perfectly clean, and there's no blowout on either sides. That's a really nice cut, makes a really nice miter or straight cut. You won't have to worry about split out or chip out at all. Now, as long as we've got this set up here, let's just say you're making a clock and you've got these small little trim pieces to cut. The smaller they are, the closer your hand's going to be to that blade. And the concern, of course, is with hurting yourself for one and getting that cut in line for two. I'll take a little piece of material like this and use double stick tape on the piece I'm planning on cutting and lay it in line with the back of that small slip piece. And now I can move that anywhere on the cut line and make sure that I'm getting exactly the right cut without worrying about the pieces chipping away and my hand being too close. It's a perfect way to cut really small pieces. It works every time, and the cut will be nice and clean. Now, we talked about all the settings on the saw. The 90s and the 45s and the 22.5 and the 30 are all parts of the saw. But there's a couple of markings that you may have seen on a saw that you wonder what they were there for. On the miter gauge in particular, either a straight line or maybe a little asterisk or a star or a diamond next to 31.6, both on the left-hand side and the right side of this miter. And if you look a little closer on the bevel post, on the back there's also a diamond or a little mark. And those are at 33.9. And you'd wondered what those are for. They're actually setups for doing crown molding. Now, you may have seen in the books that you've gotten, or maybe even the manuals that came with your saw, how to stand up crown molding and cut it in what they call upside down and backwards. But your saw actually has all the fittings it needs and all the settings it needs to cut crown molding safely, bigger pieces, on the flat. And that's what those are for. Here's what crown molding looks like. This would be an outside corner on your wall. Pretty nice looking piece of trim. What's interesting about crown molding is it doesn't sit at a 45 away from the wall. It sits at a slightly different angle. And this is the angle called the spring angle at the bottom. The problem is if you try and cut that on your saw with the miter set at 45, the resulting angle is going to be splayed. So by using the detents or offsets on your saw at 33.9 on the bevel and 31.6 here, you can make these cuts that provide a beautiful compound miter set at a perfect 90 when you're done with it. Here's how that works. What I want to do first is I'll set the bevel angle, that's the one on the back, to 33.9. And there is a mark on the back of that saw. There's also, in this particular case, a small little offset or a stop in the back to hold it there. And then on the miter gauge, we have a stop at 31.6 on the left and 31.6 on the right. If I want to cut what I would consider the left outside piece of crown, if I'm looking at it, I set the miter off to the right at 31.6, make sure that we're set at 33.9 on the bevel, And this would be the cut the saw would make. So laying it flat and making that cut makes a perfect cut. Doing it on the opposite side, spin this to 31/6 on this side. This piece of trim gets laid up against the fence on this edge. The bevel is still the same. And here's the miter cut here. It's actually pretty simple. A little bit of study and a little bit of practice with this and reading through your manual will show you how to use the bevel settings and the miter settings for crown molding, cutting it on the flat. It's a great technique to learn and a beautiful finish.